Det är bra. Underhållning. Ja, men då kan jag sitta här. Jag kan sitta här. Maybe this was occupied.
I just looked at it. I haven't seen anything.
Hello, my name is Eva. Det ser ut som att jag ska flytta hit. Jaha, May-Britt. Det ska bli intressant.
Ja, vi streamar redan. Det är inga hemligheter eller fula saker. Den är barnsäker. Vi har gjort så här barnsäker, att den är barnsäker. Så man kan inte säga några fula ord här. Och nu ska jag ta aj då. Jag har en liten testmacka här som hjälper med en massa olika åkommor. Med ett par sådana här TNS-frekvenser. Ja, vi har den också. Ja, men den hjälper inte. Jag har kört den. Men du ska göra rotfyllning. Vi hann inte göra allting. Så. Alltså, vad är det med? Jag kommer ifrån det. Jag tänker det är May-Britt som gör det. Jag har inte en. Nej, men nu är det. Tar vi bort det där. Ja, vad vill du? Är det Facebook eller vad har man? Jag har ingenting. Jag har Facebook. May-Britt har det. Ja, den är lite. Där är omtanken. Jag tänkte att man det är jättefast. Ja, det får ta Maj. Ja, men jag är inte så nog.
Det finns något nätverk.
Ja, men det verkade vara väldigt trött. Eller det var hennes telefon trött. Jag vet jag har bara vanligt. Ja, men det ja, nej, det kanske men ibland är det också En. Det är nog jag kanske, eller du.
Och så är det någon som säger jag hittar inte platsen.
This is an interest, yeah. It's not you don't, yeah, just use it if you want to advance this one. So yeah.
du som skrev att du hittade?
Men vill du säga någonting om vad ska jag säga? Jag sitter här i banan och håller koll på. Har jag tiden här? Vänta nu. Där har jag tiden här. Yes. Ja, jag tänker att jag har det. Det står inte.
Ja, det är ju på YouTube, men det ska vara kopplat tydligen.
Vänta nu, jag kanske skulle ha min sladd.
Jag har inte behövt det.
Och sen också liksom, men nu är man lite på det.
Var det du som var på vift? Nej, det var en länsgräns. Jag vet inte om
Det är typ så 35 anmälda.
Ja.
Ja. Ja.
Var det du som var på väg?
Ja.
Ja, vad bra.
Bra att du har koll.
Ja. Och du har ju sett att du har varit på
Ja, ja.
välkommen. Eller du ska säga välkommen.
Ja, men det är så bra.
Det är bra disciplin. Ja.
Då får du säga åt folk när de rör sig för långt. Gjorde en sån här tal på en nivå. Titta på nu. Vad menar jag? Ja, just det. Men du har ju nästa där. Ja. Vilket inte är så dumt. Jag tycker om att man ser nästa. Ja. Så ibland så vet man inte riktigt vad det är. Nej, men det är jag vet inte vad jag menar med den här frågan. Du går suffering I don't have the solution. Nej, men det behöver man inte. Jag hade tänkt att jag skulle förbereda vad jag skulle säga, men också ont i fallet. Jag gissar att det kommer få inspringande medan jag presenterar fortfarande. Ja, eller så kommer det inspringande senare. Jag funderar på om jag ska ta en om jag tänkte på vad är det för vänta någon minut. Hur ser vi ut på kameran?
Där?
Ja, det syns.
Det ser jättebra ut.
Ja. Att det är Eva förlåt.
Det är bra. Det är försökt att folk inte står i skenet. Det gör inte du nu. Men alltså, att man inte står som man har sådär. Då kommer det är obra.
Då syns inte den.
Nej.
Man står typ
Men
här.
det där är bra. Ifall man vill knappa också.
Ja.
Det där funkar.
Ja.
Räcker för det bra.
Ja, men ska vi köra?
Ja, vi kör det.
Vi har då det lite bortglömt. Ska jag sitta?
Vill du sitta här eller?
Ja, jag sitter. Å andra sidan kommer allting att höra som jag säger.
Ja.
Kanske så.
Eller ska jag få med henne?
Ja, det kan jag. Det kommer hit också.
Så det går bra där. Det går bra där.
So you are very welcome today to this whole day of climate future workshop. Oh, welcome. This is for the Dálkke, the Indigenous Climate Change Studies project funded by Formas, and our eminent project leader will talk a little more about that later. And it is we are CEMFOR, Center for Multidisciplinary Studies on racism. So I give May-Britt Öhman the floor. Thank you. This was Eva-Charlotta Hillsdotter, our water security expert. I'll be back. Yeah, so welcome to our climate future workshop. I will just make a small introduction. I made this PowerPoint yesterday, and today I'm just wondering what I really wanted to say. Because we made this application in 2017 and got funded, and it's a kind of massive text and a discussion on what Indigenous perspectives on climate change is and can be. Anyway, so the project started. We started up very slowly in 2018 and like full speed this year, 2019, and we will continue until 2021, but with different levels of possible. We have a huge funding, which we're very grateful for, but anyone who works in academia or any kind that is with projects knows that money runs very fast. So we are both doing the research and also wanting to continue. So we really want to find other ways of continuing this important work. So yeah, I wrote this one. Yes. We are doing it from Indigenous perspectives. So we're also trying to involve the language. So here we have welcome in 3 Sámi languages, in Swedish and English. Boris, I cannot do this South Sámi. Maybe Eva can do the South Sámi.
Yeah.
Could you do that?
Will you recommend?
Yeah. Is there a North Sámi here? Anyone speaking North Sámi?
Susanne?
Susanne? Well, you can do the Luleå Sámi. Boris works in, but I won't do the North Sámi. Well, and in 2017, when we made the application, no one could have foreseen what the situation would be today, but we could. We realized that this is upcoming and important, and Formas had this call as well, of course, understood. But it's on a world level of engagement. So what is this climate change actually about? I'm not responding. I'm not going to answer this. But what is the problem or the problems I'd like you to think about, and the solutions? Are there actually solutions? I think we all, what from our project, what we're discussing is that fixing, just the idea of being able to fix, is something you need to challenge, because when you start saying fixing, you need you refer to technology. And what does technology do? Is it the magic wand that will solve everything? Well, not really. And will we all suffer and die? a lot of people will suffer, and there are already people who are actually dying from the consequences of climate change. And yeah, again, we don't want. What we will do today is not present the solutions, but our ways of challenging and promoting different ways of dealing with climate change, but also both technology and innovations, while remembering that there is no fix, but to actually consider how we live and relate. Yeah, I already said that we're going on to 2021, and this was the main part of our application, noting that indigenous peoples suffer the consequences of climate change, and also the consequences of fossil fuel extraction, it demands taking land and destroying water. As you maybe followed what happened at Standing Rock when they were protecting the river, Niukoni, water is life. But in this fix, the search for fixing, the solutions proposed also take land and destroy water with wind power, hydropower, nuclear power, again placed on indigenous people's territories and demanding mines that are also on indigenous people's territories and destroying lands and water. I don't know how many of you have studied environmental history, but I think understanding why we have come to this is a part of relationship with nature. And I am historian of technology myself. So I'm with a feminist and post-colonial perspective. And so I early met with Caroline Merchant. She's professor of environmental history, philosophy and ethics at UC Berkeley. And her book, The Death of Nature, Women, Ecology and Scientific Revolution, 1980. The issues we're talking about today has been there for quite some time. But she discusses in this book the Enlightenment, the growth of the Western science as the period when actors started to objectify and dissect nature, and means that this is the basis for the relationship with nature within the Western science models. So then our indigenous people's models for relationship with nature. Well, if you actually look into traditional way of livelihood, you will see that indigenous people's cultures actually have maintained a very respectful relationship with nature. You have to consider generations ahead and always give back and respect lands and waters continuously. Of course, indigenous people are part of the modernity that is destructive, but if you discuss with indigenous people's communities, you will see that this idea still is very strong. But it's hard to keep it because it's often ridiculed and mocked. So I think this is what can be offered as a part of Indigenous climate change studies. It's not just any type of climate change studies. It's doing it from indigenous people's perspective and maintaining and looking at these cultural value as really part of understanding the problems and also looking to ways of actually protecting what we need to protect, our lands and waters and our climate, well, our futures. Can it be brought into Western ways of relating? And if so, then how? Well, that's what we're doing. We're acting within the academia and doing our best. I don't know how to do it other ways. And there is we have Indigenous studies internationally is a big field in the US, Canada, Australia, New Zealand. They have institutions, they have professors, even deans, whereas in Sweden is very far behind. We are behind in relation to Norway and Finland as well. So we're hoping that this can also grow in Sweden, and with this perspective of relating to nature, lands and waters. So I distributed a post that I made on this project with the project participants. You can look more into it here. You will hear some of the researchers here today. And yeah, I'm pushing the practical issues. But you will have we're looking forward to a great day or presentations on ongoing research. I am not sure what they will say, so I'm excited too. So this morning we will be here in this house 16, and then for lunch we'll go upstairs to Matikum, and Gunilla here, who is project participant, will distribute our tickets for everyone here. So just hang on to Gunilla. And in the afternoon we will be another place. I made a map. The reason why we're two different places is because we were more than expected, so we didn't have a room that enough for the number of people coming. But I made a map, and you can hang on to people who work here. Yeah, this is the map. Maybe before I end, you can just, the project participants, maybe will just say hi who you are to the audience.
Yes. I want to say hi again. Water resources, management, and water support.
Ni har hört om verkligen som temporary heritage earlier Sámi society.
Jansson, I live in Kuoljok and from Luleå Industrial Technology and
Susanne, Spik from Jansson.
Yeah, my name is Björn. I am the managing director of a company called Tannak International.
Yeah, well, with that, I actually got exactly my time.
Yes.
So I think I'll say very welcome, and so happy you're here. And please don't hesitate to ask questions. I think we said that they will talk about 20 minutes in total, and then time for discussion. And, yeah, okay. Thank you. Welcome.
Yes. And now to Susanne Spik. Ja, alltså gå inte framför annars går det bort med. Man sitter. Ja. Det är så gammalt. Är det du som trycker eller vad händer? Ja, det får du. Ja, det är det. Nej, det ska ju jobba. Det är jobba. Ja. Jag tror den är inte med. Det där var det som var.
Demokraataalkeita ja puoliskaitseita militana. Samosaakasta me ietsattiellä me kun harjana nana rights. So I just said to all of you, hello. It was a presentation of who I am in my own language, as I have grown up with since birth, Sámi language. My name is Susanne Spik, and I am a Sámi woman from Kuoljok, which is a very large area in the very north of Sweden. As a reindeer herder, I am a member of a Sámi village called Sirges. A Sámi village is a kind of association for herders that keeps their reindeer in the same area. Our Sámi village, Sirges, is the biggest Sámi village in Sweden. There are a lot of members there, nearly 500, something like that. The majority population of Sweden used to call the area we live in for the wasteland. A word that I'm not familiar with because my people have lived and worked in these areas for ages. I grew up in a traditional reindeer herding family, and I'm the youngest of 3 children, all girls. As a female herder, I saw a need to develop a technique that could be helpful for the hard practical part of herding. A technique that would function in our hard climate in our big areas. Areas do not have mobile coverage as in many other areas in the world. Together with a female colleague, Karin Kuoljok, also a reindeer herder, we started to search for someone that would help us with the developing of a new, for us, functional technique. What kind of needs based in our culture did we see then? The need to have control over the herd, expose time for the herder, make the physical work easier and minimize injuries for the herders, and also to attract young Sámi people to stay and live in the Sámi culture, working as a reindeer herders. We also saw the need to lower the operative costs for vehicles. Kan jag säga fel, men det gör kanske inte så mycket. That herders need such as motorcycles, snowmobiles, helicopters, and so on. That herders could see where the herds are on a screen instead of always have to be out there looking for them by eye. It would be safer for the reindeer too. Because we depend on a mother healthy nature, the impact of climate is always a central part of our thinking. We had and still have an environment perspective in every sort. We found our help in LTU, Luleå Tekniska Universitet, at the technical in northern Sweden. And we started to cooperate with them in a project called N4C. With support from the European Union, we get contacts and knowledge from many parts of the world. During this cooperation, the technique developed during many tests in our area without mobile coverage and a very cold climate. We opened our homes and invited them into our culture. Everyone had to understand our culture, and it needs to everybody know what kind of technique we were searching for. It must be functional for us in our special kind of work and lifestyle. Our work and cooperation in the project N4C had good results. Because of contract Karin and I had with the project, we owned the results of the test, and after a long period of cooperation, we started our company Tannak. We borrowed the name Tannak from one of our mountains in the nature where we live and work. Tannak means here and now in Sámi language, a name that also in hand with how we use our new technique and applied it in the necklaces on our reindeer, a technique that helps us to see where our reindeer are in real time, here and now. Our journey from needs today is useful technique has been a long and rocky road. Karin and I have been in many projects to continue the developing and have been many meetings and tests during these years in Tannak. And now I put an end on this story of the very beginning of Tannak and leave the word to Björn.
I continue. I will start with more of repeating what May-Britt said regarding technology. Technology has no value. There is no purpose to fulfill. There will be some technology inside my slides, hopefully not too much, but give some sort of understanding how technology can actually help and facilitate collaboration between indigenous people, and other stakeholders. And I will keep this interactive, so please stop me if you have any questions. There will be hopefully room left after my presentation as well. If you have questions, hopefully I can answer them as well. Thank you. So first of all, it has all about environmental impact. There are some different, how do you say, pictures here showing right now, like climate change, deployment of wind power plants, mining industry, gas industry, could be rainforest, trains, railways, roads, and also that our population, global population, are increasing. It has an impact on the environment, and it also has an impact on on the indigenous people's territories as well. It's the question I would like you to think about: can technology enable social innovation but facilitate cooperation between indigenous people and external stakeholders? And hopefully I can shed some light around that in my presentation, my slides, and how that's to be done. And hopefully it can give you some food for thoughts as well during my presentation. I will sort of continue with what Karin mentioned about technology. When it was invented, it was actually challenged with some huge, I would say, challenges. The environment is pretty extreme out there. There is no cellular network. It could be minus 40 degrees, strong winds, no power, and also up in the north, it could be 2-3 months complete darkness. And we need to have some sort of communication network out there between the object, i.e. the reindeer, and the user, who will have to see where the object is and where it has been. The same goes also not just for the northern part of Sweden, it's also in Africa. The same sort of thing, except for minus 40, then it's plus 50. So it's completely different, but the same sort of requirements, How can we locate objects inside these territories? Hopefully I will give you shed some light in this. This is only technology. Again, if it doesn't have any purpose, there is no value. And this is what Karin mentioned as well. It started off as a project in 2002, 2003, named N4C, where you look at networking for communication challenge communities. And that's what you look into, how can we address these challenges? How in terms of communicate in these extreme environments. And they did a lot of test beds. They tried to understand, how the indigenous people are working with the reindeer herds. Now, what kind of technology can be invented? This is early stage, in order to make this happen. In 2006, Tannak as a company was founded, and they had their first solution in place. It looks like this. This is an object. This could be, in this example, there are reindeer herds who are communicating with some sort of hotspot, with some sort of a radio link and hotspot. And they can simply communicate with another hotspot. Somewhere it has to be a hotspot where it has an internet connection. The distance between the reindeer and the last one that has an internet connection could be over 700 kilometers. That is required in these type of territories. Because it can be so long distances between, there is no cellular coverage. Of course, if you use satellite communications, also for stuff that is expensive. That's why we are using this type of technology to communicate the position of the animal, but also metadata to that position, like temperature, movement, mortality. And that is coming back to that. That data is quite valuable to understand it from an analysis perspective later on. And then it goes up to an application, and this name is On Track. So On Track is actually the value of everything. The data is carried in some sort of application that shows position. This is how it looks like. This is actually the reindeer husbandry owners are using this type of application every day. I spoke with one of the reindeer owners yesterday, saying I'm using it every day to locate where they have their reindeer. And then they can avoid other ways using helicopters or snow ice or whatever. They are quite expensive and has also an environmental impact. they can actually have this application. They can see where the objects are. But now, but there's also one thing that we also store all this data in a database. So it's also a historical database. Where has the object been, and how many times, and how we do that we sort of vectorize the map, and you can see the movements many years, what where the radar has been. There you can also see what kind of impact, like climate change or deployment of mining industries or something that has an impact on the territories owned by the indigenous people. Has it caused any change in pattern, from that object based on that one? You can see that one. So the data, I would say, is actually the most valuable thing coming out from this, more than positioning, knowing where the object is. Is it alive? Of course. Has it been killed by a predator? That could be stuff like that as well. But from an environmental perspective, you can actually see pattern. Is external factors affecting the normal, life of the object? In this case, it could be a predator. How do you do that? This is what we do. This is about data analysis. It comes all back to statistics. All data is gathered into some sort of data warehouse, where technology, but it's all of a huge, quite a lake of data. In that you can actually do a lot of interesting things. And that's what you can use, for example, land usage, or as we call it here in Sweden, realised plan, which is a plan for the reindeer's owners to show and plan, their land usage from their perspective. And they can use that in communication with other external stakeholders as well, such as authorities, mining companies, forest industries, everyone that has an interest in that territory. What we also can do, and here we're coming into more of the environmental factors, we can actually, of course, integrate this data with other external statistics data. That could be anything coming from meteorological institutions like SMHI in Sweden. That could be a road, train, animal that has been killed, accident statistics. You can see impact, like, well, if there's a railway plan in my territory has been down there, has there been any impact on killed animals and also movements, stuff like that. So this can be impact on indigenous people, everything that is going on into the territory, what kind of impact will. The next one we are looking into right now, together with Luleå Tekniska Universitet, is actually more a predictive model. And then we're coming close into using these sort of the hype words of algorithms, machine learning, artificial intelligence. Now it's get really, really interesting. So this is a research project actually kicking off right now, because we don't know. That is research, Is there a pattern we can see based on different factors? We call it metadata, like temperature. It could be disease, for time, season, year. It could be other factors like maybe snow conditions, So what we're doing right now, we're melting that into a pot. And then we start modeling to see, of course, if we see this type of pattern come on again in some sort of in the future, then we can predict what will happen with high probability. So this is quite interesting how you can use technology as well. This is, as I said, this is still on the bleeding edge. We don't know yet. But I think that's the beauty of research and innovation, and science. So this is actually just kicking off right now. It's some funding from European Union as well. But how does it, Okay, now we're talking about reindeers up in the northern part of Sweden, or in Finland and Norway. It's the same. Can you see the same sort of climate change or indigenous territories in other regions as well? I can give you, this is a real example. That's what we're working on right now. And there are only pictures, so I will explain it to you. This is actually somewhere in South America, where they're looking into the deforestation of the rainforest based on many factors. That could be climate change, It could be wildfires, as you may be seeing in the press. I think maybe now we can figure out the country as well. But one of the biggest, factors behind the biodiversity shrinkage for the forest is actually this one, the cattle. The cattle is using the rainforest as food. And in some of these countries, actually, there is law that cattle cannot they can't actually eat from the rainforest, but there is no proof. You can't show it. How do you prove it? Evidence that my cattle has not been into the rainforest. So what started here is actually, and that this has also an impact, of course, on indigenous people who lives in the rainforest. Because they see their territories shrinking because they're different. They are interested from this part, the meat industry as well. And then you have the government saying that, well, they're not allowed, but how do we prove it? So what has happened here right now that we're looking into, can we sort of give some sort of a green seal on the product that actually gives a digital evidence that this cattle has not been into the rainforest during their lifetime, which normally somewhere between 3 to 4 or 5 years. And what has happened here, and what we're doing right now, is we're putting also this type of same sensor as the reindeer. Again, it's just an object that actually is carried during the lifetime of the cattle. And then it actually saves the positions. It also over 4.5 years inside this small sensor with all positions. It can't be hampered. And it will also sense its current positions all the time as well. So what happens here that the cattle, if the owner of the cattle can see if the cattle is actually approaches the rainforest, it will send out a warning. We call it a digital defense. So he or she can take a proper action and move away the cattle from the rainforest. In the end of the day, what's about this guy, the meat producer? Well, right now they get demands from their buyers that they need to guarantee that the meat they are buying from these guys are green sealed. So here comes the other. At the end of the day, hopefully we can protect the indigenous people territories and also save the rainforest. Coming back again, as you see, so there's a link what coming up where we started up in the reindeer territories about how do you get these people to collaborate between each other by using technology? Can it facilitate collaboration between these different stakeholders? And then it could actually be useful, but it's all about collaboration. And we can show some value of technology as well. We'll give you another example. We jump to another region. This is Africa. Where's the cat right now? Well, it's down there. Down there, an elephant as well. This is also a project going right now in one country in Africa, where it started off like we looked into the national parks. And the first sort of purpose of the national park is that the animals living in the national parks, could be elephants or rhinos, whatever, they are protected. But also the risk they have is actually poaching. So how can they sort of avoid these animals being killed by poachers? That's where it started. Well, you can put again some sort of sensor on them as well, so you know where the animal is. If the animal is actually trespassing the border, digital fence, the park ranger will receive a warning that tells them, hey, this animal is actually trespassing, is getting outside these outdoor bounds, please bring it back again. Well, that's one use case. On the other hand, you have the indigenous people. What are they most afraid of? The predators. Because usually, these national parks, they don't have physical fences usually. With some fences there, they're quite big. So these lions actually or could be other predators, are getting into the villages for food. Again, what are they doing? They are, of course, scared to kill them. And then they get some sort of a conflict between the national park owners. It could be also the regional or the governmental authorities and their rights. Well, if you're using technology here, and you can actually facilitate that as a collaboration between these ones, and you can put some sort of control, not just for poaching, but also for the indigenous people in their territories. But that can actually ease up the friction and hopefully enhance the collaboration between these people, and also supported by the government. This is also supported by other interest organizations as well, like WWF. The next one coming in here, that is United Nations. This has it was sad background from Tanzania. The most valuable asset usually for a family in Tanzania is the cow or the cattle. That's their wallet. And problem is that there's a lot of thieves that like to steal that wallet from the family. So how does the family protect their wallet? By guns. That's why that causes a huge conflict between the asset and the ones wanting the cattle. So what we are looking into right now, and we're doing that sort of with some communication with the United Nations as well. Can we put some sort of identification inside the cow, outside the cow? So the cow is actually identified, and it will be send out a signal if the cattle, the cow, is moving in some sort of direction. So the cattle value, steel value, should be minimal. And now I got 5 minutes as well. I do it. So this is just starting off. This is going on. As I said, food for horse. So where are we going as a company? Or where are we going in the way the company is looking for the climate impact indigenous people? Well, some of them are not indigenous people. It has an impact. One area we're looking into right now is actually outdoor activities. Outdoor activities is increasing a lot in this region. And it has an impact on land usage, and it has an impact also on indigenous people. So what we're doing right now is actually we are exploring and we are putting trackers or sensors on these hikers. We're using it for their sort of need of digital experience. They can see what they have done. I should show it to the family. Friends can show the route. To be some security as well. But usually in these areas, there's no cellular coverage. A lot of these hikers are getting up there and they go, something happens, I use my telephone. Good luck, there's no cellular network, or there's no battery. Please remember that one if you're out hiking. The mobile phone is not an emergency unit. It's just like the people believe in it. So how can we do that? Yeah, we can use the same technology here. But not just for digital experience, but also for emergency. If something happens, we have the panic button they can press, and the geoposition will send out to the 112, the emergency, and they can send out the patrols to locate them. But also, from an indigenous people perspective, they can use that to see where have they been. Are they actually out of bounds where they shouldn't be, where there are reindeers in the time of year where they shouldn't be disturbed? Yeah, touch that one. There you have the smart health, but also then smart agriculture, which is also coming in. This coming into the increased population, climate change as well. We need to get more food on a certain area than we get today. And we do it we also have water issues. We need to make smart watering. Going right now, you can see that some of these farms, they're putting water on the fields full speed. even though there's going to be heavy rain in 2 hours, there is no link between the weather forecast and weather. That's also how they apply this type of technology for the best of civilization. Well, has static link to indigenous people? Could be. I will show you how we are actually applying this technology to solve some really, really tough challenges in our global world. That's me. And please remember, products don't solve problems, collaborations. That's me. Thank you. I don't think I have any time for questions.
We have time for questions. I think it will be a presentation of a fantastic company, Tannak, which Susanne, Spik, and her colleague Kuoljok came up with the original idea and founded it from the beginning. So this is really interesting to see how it has the development. So, time for questions.
Thank you. It's really exciting to see what you're doing. I've got 2 questions. One is technical, which is what is the mode of communication then? So
this is all for both of
well, that, I mean, but I do think that it is a question. How does it actually work? And then the second question is, who owns the intellectual property from this? So how is the finance run? Who benefits from this company?
Can I answer? Okay. Susanne. What kind of magic sauce do we have?
Who owns the property? Vem äger the idea? Ja, den intellektuella idén. Ja, det var en känslig fråga just nu. Hur tekniken fungerar, man har en mobiltelefon eller en computer. Trycker på, först har du satt halsband på renarna. Vi har gjort en necklace on rain. 10% av renhjorden bör vara uppmärkt eftersom renarna är klockor. 50% av renhjorden. Då kan man se, man väljer själv vad man vill ha, hur många uppkopplingar man vill ha per dag. En del vill ha 1, en del vill ha 1000. Våra nätverk du kan koppla upp oss så många gånger som helst. Det finns ingen begränsning. There are no limits how many times per day you can look for the reindeer. Det som är intressant tycker jag, det är datan som vi kan använda oss av. Hur går renarna? Vad är det som skiljer det här året mot förra året? Vi kan påvisa inför exploateringar i våra områden att här finns det redan. Oftast får vi frågan att det finns i varje. So you can actually tell where the reindeers are moving, so you know where if there is a mining company coming and saying we need this land, then you can actually prove, there is proof that the reindeers are grazing in that area. What local people, yeah. Plus att det ligger en massa andra applikationer. Identity, försäljning och så. Identity if you are selling the reindeers. Yeah, and how is it about intellectual property? Alltså den äger idén.
So it's your idea. You have gone to the university and the company with this idea. So who then profits from it? Do you get the money from it? Or does that work?
Vi skrev ett kontrakt när vi tog fram tekniken. Det var vi som var initiativtagare som äger produkten. Så att säga.
Det var så konstigt.
Ja. Men sen är det så att det är inga affärsmän i den bemärkelsen att vi har pengar.
Och vi don't have the money business people.
Så i första hand så vänder vi oss ut i Norrbotten, superfinansiering och även affärsänglar där. Men här kommer det 2 kvinnor från en Sámi.
Vi var med 2 kvinnor från en Sámi.
Det blev väl inte alltid så väl bemäkta och vi fick aldrig loss de pengar vi behövde.
Not always någonsin, men vi fick get money.
Så vi fick åka till Stockholm och träffa affärsänglar från Stockholm. Och de har investerat pengar i bolaget och idag är den inställda just nu inte väldigt mycket. Så idag.
There is no.
Det är ju sorgligt historia, men det är sant.
Do you have any comments on that? No?
That's true. It's been a long, I would say, journey with the company. It was, the solution that was brought forward in 2006 by Susanne and Karin, but was in an early stage. It had this, I would say, features as well. It took taken a long time until we have found, the way going forward. Based on, not the need has not disappeared. Still there, I would say the heritage and, with, up in the north with indigenous people and reindeer herds is even more important right now, as it's also now spreading over the borders in the Arctic Circle to Finland as well.
Could you just specify just the specific technology that you've added to this idea then? Is it Wi-Fi? Is it?
No, it's not Wi-Fi. It's not Wi-Fi. It's a standard. Usually, this is like we've done this as a standard, and also because you can share it with other, I would say, interesting parties, I would say, in the industry. So it's using radio technology, usually developed by actually the military in the US until the early 2000s. But we're using it for a completely different purpose. So it has a standard behind it. And that is important. Otherwise, you have to develop all the components by yourself. I would say the value is the application. That's where it comes up, Not all the other stuff is just gadgets, And the big value is the application, what you can do about it, and how the data can be used as a tool for communication between the indigenous people and other external parties. May that be authorities or mining companies or national park owners, I don't know. But that's sort of the value. And that's what we're looking into now, getting into more of the next stage of analysis using algorithms and machine learning methodologies.
Yeah, I think for you, okay.
Well, I just want to say because our foundation part of the climate change project is to work on this. How can Tannak become a good example? How can indigenous audiences be supported and keep the cultural value of indigenous peoples in the school? So that's the idea of our collaboration being part of the project. So it's an ongoing work we're doing, and it's doing this since. But I was part of the first trial in 2006 when they were testing the technology, and so we started collaborating on the application. So we started again talking in 2017 or 16 maybe. But we always in touch. But I just want to stress that that is the part within our project. So the Tannak company is one thing, but our collaboration is how can Tannak do this and do promoting indigenous people's innovations and ethics and so on. It's important to know there's different things.
Very true.
Oh, there are many people. I can't remember something here.
Jag får på svenska.
Okay.
Jag vet inte om jag har förstått rätt, just för att jag inte hänger med så bra på svenska och engelska. Men jag tycker det här är jättefint. Jag har också hört Karin Kuoljok innan, och det är fantastiskt med samisk innovation och allting. Men jag vet inte, du sa det lite nykolonialism när du visade det sydamerikanska exemplet. Jag tror inte den urfolkssyskon som du visade är i samma maktrelation som samer kan vara. Och om jag uppfattade rätt är era uppfinning mera någonting som gynnar storgodsägarna, boskapsskötarna, inte urfolk. Och ja, jag skulle helst vilja att det inte promotades i vårt namn.
Oh, no. I got the point. I got the point. No, of course not. It's all about, what we can say, it will hopefully protect the rainforest, and we can stop there. That's sort of what we are supporting the local authorities with technology, and then taking it to the next step. Maybe I was too brave, so apologies if I'm stepping on the toe. Mistake.
Thank you for a really interesting presentation. I was just curious how this has been received by other people in your Sámi village. You can say something about that.
Hur har det tagits emot av andra? Det var en bra fråga för att det är blandat. Det finns de som sa att det blev ett hot mot kulturen, mot den traditionella rennäringen, hur man sköter renar, och det var någonting ont för näringen. Men jag sa att man kan vända på det också och säga att man kan ha möjligheter att i systemet kan man plocka in historik, samiska. Det är bara jag som begränsar mig vad jag inte vill ha i nätverk. Så jag såg en möjlighet att ungdomarna ska få kunskaper på platsen i arbetstillfällen där man behöver kunskaper. Så att bli motiverad att behålla det som något väldigt viktigt.
But there are other possibilities because as an opportunity to share the Sámi culture.
Sen är det ju så att vi är en näring, en mikronäring. Som precis som många andra företag uppe i norr är mångsysslare för att överleva. Att man måste få in pengar hela tiden från någonting. Och att dra ner bensinkostnader och försöka hålla nere kostnaderna för rennäringen, det är väldigt viktigt idag. Plus att jag kan uppleva, det vi så sällan pratar om, det är att det är en miljöprodukt. Så vi också håller ner utsläpp från skotrar och helikoptrar och så vidare.
And we can actually reduce the fuel costs and the emissions.
Yeah.
So one of my questions touched on both of the previous speakers. How, if you're looking to expand this and in South America and Africa, how do you build trust with Indigenous groups that their information that they'll be giving to you is looked after? I think we touched upon this earlier.
It's an interesting question. So what data security and data governance?
Because I think you've been mainly dealing with local authorities or the UN as opposed to the groups themselves.
Mm.
How do you ensure that there's trust and that relationship with those groups that be potentially giving you this data and be sure that it's going to be looked after?
Yeah, it's sort of, yes. That is sort of in discussion. It's quite interesting mentioning it. We will not own the data in these countries. But we will not own the data here in Sweden as well. We are collecting the data for reindeers in Sweden. We don't own the data. The data is owned by the reindeer owners. But coming into other regions like South America and Africa, then there will be, I would say, any actor, whatever it would be, any authority or owner that would have this sort of the governance of the data. There goes the light. So it won't be temporarily deciding in the Tannak network. It could be complete different network. This is sort of, again, it's a technology that is stored in the cloud. So, which means it has no borders.
The local authorities, the owners of that, how do they connect it?
That is also quite interesting.
There are different dynamics.
Yeah, we are in early phase there, still just in pilots. I would say these challenges have not been fully addressed. It's on the table, and we need just to be there and as an, I say, supporter, of different groups going forward. But it has also to do with the countries, I would say, data privacy laws, and I completely agree with you how this data can be used. And hopefully, you know, data can be used in 2 different ways. And I like the positive one.
Yeah.
GPS on has become increasingly common in both management and research during several decades now. So it's used. You have found some technical solutions for overcoming these challenges that you say with the environmental and economic and electricity. So of course broadens the possibility to use the technology. But then of course, as others have mentioned, it's how is the technology used and who uses it and who owns the data, of course, very essential. With the radio custom data that you mentioned, this has been a very ongoing discussion. I suppose on that, but it has been extremely important in Sweden that the Northern District owns the data. So this is of course a key issue. But maybe I have a bit more to say about that. It was more a comment.
Okay, yeah, we'll continue. So we have one more question here. I actually have a question for Susanne. Maybe I should say both in English and Swedish. Yeah. So I'll start in English and now. It's 2 questions. I'm most really interested in this. I've been collaborating with another for some years also with how we can use GPS and both the pros and cons. So I'm curious first as to your estimation of the 10% on how many animals need to have the power on for it to function. And I'm also curious on your perspectives on what is the balance between the add value in terms of the information the herders get, but also the concern that the herders also receive from perhaps having too much information and always knowing where the animals are. Så 2 frågor. Det ena undrar, hur har ni kommit fram till vad bygger den här uppskattningen 10% av rendagar räcker för att ha en hyfsat god uppskattning om var djuren befinner sig? Och hur ser balansen ut mellan den information som man får, att den alltid är tillgänglig, och den oro som också skapas av att hela tiden veta det. Det finns både för och nackdelar. Så hur har ni hanterat det och hur ser era reflektioner att ha jobbat med det här?
10%.
Ja, men det var det täcker ganska bra. Ibland kan det bli vissa luckor. Och ibland, det var våra erfarenheter som vi gjorde. Och sen är det en kostnad för den som ska köpa.
Har ni testat att ha mer än 10%?
Nej. Och det som skiljer vårt system från många andra är att vi jobbar i områden utan kommunikation. Sätter upp massor av stationer. Och kostnaden är ju på det sättet mycket lägre än vad andra kostnader är. Vi har haft en räckvidd på 12 mil ibland mellan halsband. Sen den andra frågan om stressfaktorn. Jag som djurägare vill ju ha total kontroll på mina djur. Veta var de är för att jag vill behålla dem. Jag vill inte att de ska vara ute på vägen eller gå in till grannen. Eller... Jag vill ha total kontroll. Så det är väl upp till var och en hur man hanterar det här. Vill jag gå in 10 gånger om dagen så gör jag det. Vill jag bara gå varannan dag, det är upp till mig som djurägare. Så den stressfaktorn, det får ju var och en hantera hur man vill. Är du nöjd?
I want to take a little bit to over discuss regarding the data price and data application of the data. And as Pagani said, that is in terms of commitments into Africa and South America, that the ownership structure of the data is yet to be decided. It's something you ought to address.
Yes, agreed.
And I was wondering how you're going to do that. If you have one idea, you
address this issue together, but who would be consulting, who would be actually develop an infrastructure? Because it feels like a very point.
It is. It is. It is.
As it goes to empower indigenous people.
Yeah.
To what extent, or if the collaboration with Svenska comes in that area? Or, yeah, you just reflect on that.
Yeah, it is. It is. We don't own the data. No, we own the sort of the application, call it the backbone, or the sort of the technology system that collects the data, right? But that's sort of, again, that's sort of in the cloud. So there could be different clouds. How that will be addressed in different countries, it's not up to me to answer, because it could be different. It will surely have, you know, the national interest, of course, the interest of the ones who are producing the data and can take leverage on the data as well. But it's a delicate situation. It's the same here in Sweden as well for all data, who owns the data, and how do you secure that the data is governed in a good way. So this is sort of transparent for all these, all these repositories that are saving data. So yes, I agree with you. And there is no direct answer on it. It has to be sorted out through some sort of negotiation, discussions, and dialogue with the different parties, and with and also with a good cause. Look at on two sides. We're really trying to do something good here, and that's how we also can solve how data can be used and not misused. This is actually true, and that's what we're looking into right now. We can only be a member of that discussion. We can't solve it. It's up to the parties to come to an agreement there.
There is a lunch. So there are also more questions, but there is a lunch time where you can approach Björn and Susanne and ask more. So now to Ida.
Ida Jansson, welcome.
Thank you. Let me see here.
So I'm Ida, and I will present my work in this project Dálkke. And it's a work on the relationship between a plant and flowing water, and what this relationship can teach us about energy harvesting or energy conversion. To start with, just some short words about my background. I was born here in Uppsala, and I did my PhD studies in Luleå and also in Kuoljok along the Luleå River. And my PhD studies was about vibrations in hydropower machinery. So I would say interactions between flowing water and rotating steel. And so this work is done from my perspective as an engineering scientist. And it's also a way of challenging my own perspectives as a fluid mechanician. and fluid mechanics is the research field. And what is this then, fluid mechanics? Fluid mechanics deals with motion of fluids. And what are fluids then? Air, water, or blood, combustion gases. That's some examples of what a fluid is. And this can be applied to a wide range of areas, such as lubrication in bearings and global climate models. That's two examples of this. And I do this work then in Jokkmokk in Sámi, where I also live. And this work I do together with the plant, Oassje, water horsetail, or the parken in Swedish, and a tributary to Luleå River, Barnbäcken. Who is then this plant, Oassje? It's one of the oldest surviving vascular plants. Vascular plants, what is vascular plants? Non-vascular plants are mosses and algae, for example. So vascular plants have lignified tissues that can transport water and nutrition. And here we have a water horsetail in a dense stand. And they grow in nutrition-poor wetlands and lakes. But they still contain a quite large amount of nutrition. And this can be explained thanks to their deep root systems. So you can say that they function as nutrition pumps and bring nutrition from deeper soil layers. Water horsetail is and has been important for survival in Sámi. And for example, it's an important part of the meal for reindeer in the summer. And settlers also harvested this plant. It was, you can say, it was the second best choice to harvest for animals during the winter. But this is not my own perspective on this plant. My perspective is on the relationship with the flowing water. And I will now show you some pictures, also, some clips from my observations of this relationship. Thank you. what is going on here in this relationship, and what is the point of working with this relationship. I show you a short clip from, this is from this spring, a student project that I had together with students at NTU. It's from a water channel in the lab. And it's the same physical phenomenon that you saw with Oassje. And this is in slow motion. So what's happening here? When the flow passes the cylinder, it curves inwards, and when this vortex detaches from the cylinder is pushed sideways, and it happens alternately on both sides. And the motion of the cylinder in its turn feeds back energy into the flow, so this vortex speed is enhanced. So in that way, this is an example of an interplay where both it's not the cylinder that causes the vortices or the vortices that causes the motion. It's an interplay where they interact with each other. Yes. So, and this interplay is called vortex-induced vibrations. So, here you can see the vortex street behind one stem of Oassje. And what is the point with studying this then? And as I said before, I do this from my perspective as a fluid mechanician and my background having studied vibrations in hydropower machinery. And when I dealt with vibrations in hydropower machinery, I dealt with them as a threat to turbo machinery. But at that time, I also got aware about that vibrations may have other meanings. Vibrations and unsteady fluid motion doesn't have to be a threat. And to give an example of this that I find very illuminating is flight. Some of you might have heard about stall. Some airplanes can stall, and when they do this, they lose their ability to fly. What happens is that if this is a wing of an airplane, you have the incoming flow. The flow detaches from the leading edge of the wing and forms a vortex. And this vortex detaches from the wing so that the airplane loses its ability to fly. But the same phenomenon happens for insects, birds, bats, these things that fly from the trees, copters, I think they're called. And they depend on this phenomenon. They use the leading edge vortices to fly. So that's an example how traditional engineering have missed the very valuable aspects of how things work. And vibrations and unsteady fluid motion is a threat to turbo machinery, but it can also be utilized in energy harvesting, which is a growing field today. But my work focus on studying this relationship. So I have not applied it to energy harvesting, even though it is a possible application, since there exists research on how to harvest energy from vortex-induced vibrations. So what I will continue with next summer, doing field experiments, is from video motion analysis, look at the amplitude and frequency, and also find ways of relating this to the mass ratio and damping of the stem, which determines this motion, the natural frequency, water velocity, and amplitude. So that's my plan for next summer. I will also say a few words about this related to energy harvesting and what's the current situation in that area, just briefly. So, even though if this is a good example of relationship with a good way of converting kinetic energy, how can this be useful? And if we are interested in electricity, we also need a generator. We need to convert motion to electricity. And conventional generators convert mechanical energy to electromagnetic generators. But there are also other choices that are more suitable for converting vibrations to electricity. And I think we'll see. Maybe I'll say this as well. So what is energy harvesting? This field that is growing today. It usually refers to technologies that harvest ambient energy from vibrations, fluid flow, or human bodies. Still, most research in this area, still most work is on a research stage. So there exist very few commercial examples. But the applications areas are, for example, then miniature remote low power sensors, biomedical devices, Internet of Things, and wearable sensors. Those are the application areas that researchers in this area promote. This also relates to the work of Tannak. Since I guess remote sensorings can be referred to as Internet of Things as well, if I understood correctly. Yes. So piezoelectric materials is one kind of generator.
Here are some examples of applications with wind flow. And tribal electric nanogenerators is another example. This is so very new and still at the research stage. And energy harvesting connected to mitigation of climate change. What are the prospects for mitigation of climate change? That's a question that, of course, is highly relevant for this. And to be able to answer that question, what this way of converting energy can do, we also need to look on how acute the situation are. This is a diagram of CO2 emissions up to now and mitigation curves to stay below 1.5 degrees. And I chose this picture just to show how we need ways of mitigating climate change that work. We don't have time to work with technologies that take 10 or 20 years. So that's why I also would say that the potentials of energy harvesting, if you look at the contribution to mitigation of climate change in the near future, is very little. It doesn't mean that this might be an interesting field, but when it comes to mitigation of climate change, I don't believe that it's gonna solve any problems in the near future. I do believe that this might be good when it comes to self-powered sensors and Internet of Things, in the way that Internet of Things is important to when it comes to developing demand flexibility of the electric grid. And this is important if to move away from big utility scale electricity production. We also need to develop flexibility in demand. I also think that if energy harvesting should be of any use for indigenous people, it has to be developed from within the communities where the knowledge needs exist. And I think here, of course, there are possibilities here, and Susanne and Karin have a very valuable experience in this field that can be used to build on a future project. So, I mean, it was quite big discussion here about how to regarding rights, for example. So it's very important to, if you deal with indigenous innovation, to do this in a good way. And I think this technology can be of interest in such innovation projects. But I mean, I cannot. Since I myself don't have these perspectives, so I cannot, as I say, do the innovation myself. Yes. So that was.
Yes. So we have time for some questions.
All right, thank you. I'm KPH technology. I'm interested in the technology of some cases just an analogy for the fork. So you wouldn't be able to actually harvest the plant itself, or would you?
And I think you could think about a system. It depends on how you develop the system, but when you actually could make use of the stems itself. But my interest in this is mostly to learn about vortex-induced vibrations from this plant. But of course, you could think about systems. For example, this material of the Oassje, if you make this in a flexible piezoelectric material.
So potentially, though, with you were showing with the videos of the reeds moving and the vibrational energy, could it be used to help monitoring inside waterways? Sort of like some different sort of sensors for the water, because often it's a very expensive element. Like in New Zealand, there are a lot of Marais and Māori groups who like to carry out their own monitoring, irrespective of what's going on. The equipment for that is very expensive. But this sort of, between the work that we're showing here, some of the other ideas about some more micro technology to do this may become a bit more feasible.
Yeah, I think that's a possible application to this. Since you could, you can have self-powered sensors, and with those materials that are also becoming cheaper, it's possible.
I have a question. Have you had any discussions, or do you know about the biggest Swedish company, Vattenfall? Are they interested in such things? Do they put money into research or something like that?
Unfortunately, I can't really answer that question, since I don't have any collaboration with Vattenfall myself. I have some discussions with one person working with research and development. But it would be wrong to give his views. So I can't really say anything about that.
Thank you so much. It's really exciting to follow your work. Our collaboration started when you approached me on delivering on your knowledge from these two things, turbines in the disturb talking about vibrations at the waters. So I find this really important. I'm a historian of technology, so I've been looking into the history of innovation and what happens to innovations and how hard it can be to get through with new innovation. For instance, I know there's an article that was written 10 years ago regarding wind power turbines. We have, I'm not a turbine expert, but I can see what the design of wind power now is actually like giant versions of windmills that take a lot of space, and there's huge wings that kill animals, insects and birds, and also throw away in a cold climate. They can throw away like big chunks of ice, like 100 liters. So it's very dangerous. And this article talked about that there is a resistance to us innovation. It's in history of technology, STS, the correct path dependency. Thank you. You get stuck on something, and it's because of the enterprises have already invested in enough of the technology you want to design. So if you want to change away from that, we need a massive support in this. So what I'm curious, because we haven't had the time to discuss that, is
said most of the work is on the research stage. Do you have a global overview what it looks like? Is it well funded elsewhere? What do you see when you look out?
When it comes to energy harvesting, I see quite a lot of research going on, but I'm not really sure where this where it's heading, and my impression is that it's still very much in the lab. So, and if this should be able to change, it has to be implemented, and you need to find ways of working within the society with those. And I haven't seen any such examples of this. But
Do you have an idea why? Is it this practical with them talking about?
Yeah, but one possible explanation is that the potential isn't that great, since we're talking about low power. Even though we're talking about applications as sensoring in areas where you don't have any grid, but also path dependency, as you're saying, and it takes time, of course. I think this thing, the triboelectric nanogenerator here, for example, I think personally that it might be promising. Still takes time, and this what's it called, or conventional generators. They have really shaped the world. So of course it's very heavy technology that has shaped the world, and
paradigm shift.
Yeah, and it's trickier today, since we can't really wait 20 years for some new generators. We need to use what we can today as well.
Some more questions?
No, there's still next. I just want to say again, just on the technology here, we are already the way that we produce and consume electricity very dependent on a great national grid that is built and designed in a specific way, and it's not even possible in Sweden to generate their own electricity and go back and forth into the grid. Whereas it's examples elsewhere. I think in California we could do that. You actually produce your own electricity and it goes into the grid, and then you get reduced electricity fee. That, whereas in Sweden we have now a system that even if you consume a very little electricity, you still get a huge bill for this grid cost. So it's a matter of quality. You have to see the innovations and ideas and design and things of political decision.
Yeah.
So I think that's so exciting. The work looking at it, like how do we all put this together into actual things?
Yeah, I was talking about flexibility and demand. When it comes to the grid, and I think that's one reason why low power matters as well. When the consumers will matter.
What is low?
Inte så mycket kraft helt enkelt. Alltså microwatts. If you think a sensor, for example, a cell phone, and of course, if we designed cell phones in a way that they would work with low power, we could power them. Lågeffektivt. Ja.
lågeffekthus, low power.
A watch, wearable sensors.
Overall energy system, like how much of our needs can be
Yeah.
covered by the technology?
I have searched for such estimations since that's my question as well, and I haven't found any such estimates. And I think, I mean, one reason for this is that it's not, the technology is not so developed. So,
Thank you for showing those films. I thought they were beautiful. Both the ones in the lab actually and the plant back and forwards. I was curious to hear your thoughts and what happened when you started studying this plant, or what was it that pulled you into it? Was it this kind of beautiful dance between the motions of the water affecting this, and what were some of the sort of I mean, you talked about this briefly in your presentation, but there's something underneath that I think is really interesting and intriguing in terms of what it might say about other areas and how we live our lives.
I'm not sure if what got me interested in is if it was because of it was beautiful or I think, I mean, the reason why I got my eyes on this plant and the regular motion was because I was interested in vibrations, and I also knew about this application with the energy harvesting, and I probably wouldn't have been interested in it if I wouldn't. And I think, I mean, the story I told about flight and leading edge vortices, those stories have been important for me in my way of understanding fluid mechanics. Did it answer? Yes.
How did you notice that movement though in the first place? So did somebody tell you and say, look at this strange plant? Were you just walking along the lake? What drew your attention to it?
I was walking in the surroundings of Jokkmokk, and I actually crossed this den stora kraftledningsgatan, the huge power lines that where all the power goes to the south of Sweden, and there's a little creek there, and in that creek.
Sorry, that wasn't my question. I was just really interested. So I'm thinking, I'm having a slight moment of anxiety about how both of these talks have talked about instrumenting the world, of putting sensors everywhere, of attaching small things. And I have two questions actually really about that. One of them is, what are going to be the costs of producing all these instruments? How will they survive? How will we manage them if we've got millions of them distributed in different places? What happens to them and the carbon cost of making them? And secondly, what happens when we know that our world is instrumented to that level? What does that do to us? So the first question is a more practical one. The second one is just kind of for us. What do we? I mean, if you're thinking about the energy benefits of this process, how does that relate to the energy costs of the production of millions of low power sensors and devices and internet
of things? I'd say I agree with you, and I had those thoughts myself. I guess it all matters about how we talk about this, and I think it's also important. I mean, who does the research about this? When I think about the research papers I have read on energy harvesting, I mean, most papers mention this, the application of this quite briefly, and okay, we need energy today, and then they mention those applications that are, let's say, that are mainstream applications that we talk about today. And I think what you say, I mean, this is what we're talking about today. We're talking about Internet of Things. So, I mean, I'm skeptical to what that is, Internet of Things, but I also see that, okay, it can be something useful in the grid that we need in the transformation of the energy system. So, I mean, it all matters about who is it that has the power to decide what it can be used for.
Yeah, maybe time for some, or we have the lunch now, so you have more time for talking to Linda. Yeah, and also some practical things about the lunch and where we continue in the afternoon. Oh, thank you all.
So we can do some practical stuff now, because when we start at 1 o'clock sharp, we are in a different place of this building. Well, it's a huge. These are many buildings together. I don't know how many of you out the map, but we are here in the morning. We're going upstairs to the lunch, and then to the other, like, far end by you saw the big bucket, the new building here. But you can always hook up with us who are working here, so we can show you the way. Let's see. Yeah, we have it here. And we will be moving all our stuff from here, so you better take them all. I wonder, it's not open. Well, it's the room is open, Matikum is open, but the food is not available until 11:30. They're very sharp on that one. But as I said, everybody here will get a ticket. Those who are coming for lunch, and Gunilla will be the distributor of them. But if you don't intend to use it, please don't take it. We will get on this. So I think we'll stop there to meet for lunch. We have tables reserved, so kind of free time checking out meeting at the lunch, and then at 1 sharp, because we want to start with the with the presentations at 1 sharp. So be a few minutes before. Thank you.
Då pausar jag här nu.